inhibition tests and study of metabolism in fungi that deteriorate stony materials. Introduction. All stony materials exposed to the action of the nature deteriorate continuously as a result of the action of physical, chemical, and biological agents. The problem is more serious since most of the historical buildings are located in urban areas and close to industrial centers. Although generally atmospheric pollutants are harmful to organisms, sometimes they can promote microbes growth. Regarding this, it has been proven that kerosene, one product obtained from oil, biological agents have long been known. Algae, lichens, fungi, bacteria, and even higher plants have an extensive community capable of carrying out chemical and mineral modifications in the different types of rock and minerals. Fungi have different mechanisms of biodeterioration that can be grouped into two categories: physical and chemical. These processes are developed mainly in two ways: through the production of organic and inorganic acids. Other mechanism of alteration is the complexes of chelation that, for example, many organic acids from excreted by fungi. Objectives of the work: a group of different fungi isolated from many kinds of Spanish monuments was used in present study. This work focused on three main objectives: explore metabolism of fungi harbored in the stones by means of HPLC, study effect of four biocides, for example actidide, mergal, prebendol, and tigo, on fungal growth and sporulation. Electronic microscope examination of the growth of those fungi on the stones. Spanish monuments used in present study from Cathedral of Salamanca and Cathedral of Toledo. Materials and methods. Materials and methods. Culture media. The cultures medium used was the Sabic-Dox medium. Microorganisms: Asparagus niger, Fusarium oxysporium, Penicillium frequens, Penicillium sticky, Trichoderma basidiconacri raffi, Trichoderma verdi, Alternaria alternata, Phoma glomerata, Phoma eubirana, Mocor hemilis. Biocidas, Actidide GW, Mergal B, Tigo, Prebendol. Study of fungal growth under a scanning electronic microscope SEM. Hitachi scanning electron microscope was used in present study. Quantitative analysis of phenolic acid. The phenolic acids used as standards were as follows: gallic acid, 4-hydroxybenzoic acid, phtisic acid, caffeic acid, phenolic acid, serinic acid, 4-hydroxyphenyl propionic acid, acid rigomeric. Study of fungal growth under a scanning electron microscope. A Hitachi scanning electron microscope was used in the present study. Fusarium sub was the fungi that produced the largest number of different acids and also generally in the greatest quantity. We see the effect on isolated fungi. It is observed that under in vitro conditions, Axidid is the most effective product, and on the contrary, Tigo is the product that requires the highest concentration to inhibit microbial growth, especially for Penicillium and Fusarium reticulatum. It is observed that under in vitro condition, Axidid is the most effective product, and on the contrary, Tigo is the product that requires the highest concentration to inhibit microbial growth, especially for Penicillium and Fusarium reticulatum. Electron microscope examination of the growth of those fungi on the stones. When Aspergillus niger was grown in the presence of 0.1% Axidid concentration, at which the fungus was inhibited in the petri dishes tests and added at the same time as the inoculum, growth appears to have been inhibited the conidia and hyphae. It appears that the inhibition is completely figure 4a when Axidid was added 7 days after the fungal inoculation of the specimen. Figure 4b, it was possible to observe important changes the mycelium, such as swelling along the hypha and also at the tips of the hyphas. Figure 6 shows some areas of hypha affected with very obvious stresses and deformation. In other houses, multiform adhesions appear on the hypha. When Fusarium sub E was treated with concentrations of 0.2% of the antifungal agent, the structure changes and the morphological modification were very marked. Figure 7. Thank you.